Hello, in this video we will talk about the domain of the decomposition function and also how to decompose a function. Alright, so first of all, the domain. So when we think about the domain of a composition function, such as f of g of x, we must consider both the domain of the inner function and the domain of the composition itself. Okay, so for example, let fx equals to 1 over x squared minus 1 and g of x equals to square root of x minus 2. And I want you to find the domain of f of g of x. Okay, so since the domain, you need to consider both, which is the inner domain and the composition itself. So the first thing I would recommend you to do is try to compose the function first. All right, so now let's try to do this again. F of g of x equals to what? So g of x equals to square root of x minus 2. So I have f is x minus 2. All right, and then you want to substitute all of the square root x minus 2 in the x, right? So this is equals to 1 over square root of x minus 2 and then square minus 1, because in our original function we want to square the x. Now x has become a function, so that means I need to square whatever the whole function, in our case would be the square root function. Now we simplify. I have what? Square root and square, they cancel. I have x minus 2 minus 1, which is x over 1 over x minus 3. So okay, when you think about the domain, you need to consider two parts. One is the domain of the inner function. So the domain of the inner function in this case will be g of x. So here is a square root of x minus 2. So that means everything inside the square root have to be greater than or equals to 0. So that I have x has to be greater than or equals to 2. And now the second part I need to consider is the composition itself. After you've done the composition, the function becomes 1 over x minus 3. So the domain of the fx function should be what? F of g of x function is everything but x cannot equal to 3, because when x equals to 3, the function is undefined. So now if we combine these two together, I draw a number 9. I know that, hey, my function has to be greater than or equal to 2. Everything greater than or equal to 2, the highlighted that part. On the other hand, my function, they can be 3. The 3 should be a circle. So oops, sorry. 3 has to be circles. 3 cannot be included. So that means our function, the domain of the composition function should be is what? Everything greater than or equals to 2, but not equals to 3. Union 3 to infinity. Because, like I say, you need to consider these two parts. So that's the domain of the composition function. Okay, now let's try this example. If it's given fx equals to 1 over x minus 2 and g of x equals to 1 over x, I want you to find the domain of f of g of x. Again, the domain has to consider two parts. One is the inner function, the second is the composition itself. So now let's composite the function first. Try to pause the video and do it by yourself. So g of x equals to 1 over x. So that means I have f of 1 over x in here. And then the next part is I am trying to substitute every 1 over x for the x into the fx function. Then I have 1 over x minus 2. Okay, wow, that doesn't look like nice. It doesn't look nice at all. So what can we do? Well, we can simplify it and make it look nicer. Now let's try to do it. So how do we simplify it? Find the common denominator first. Well, I can have 1 over x minus 2x over x. You multiply x and x at the same time. Now they have the same denominator, so they can merge these two together. I have a 1 over 1 minus 2x over x. So you already did that in Math 19.7 or 99. How do you do this one? You flip the function, right? So this is going to become x over 1 over 2x. All right, if you forget, please review how to do a fraction operation in Math 99, please. All right, so now this is the done simplified version. Okay, so what do we do next? We need to find the inner function domain and the composition domain. So for the inner function is the g of x function. Well, we know that from the g of x function is the reciprocal function. X can equal anything but 0, right? So the domain is x not equal to 0. But for the composition function, the domain is what? It's also a reciprocal function, but we don't care about the numerator. We just care about the denominator. The domain is 1 minus 2x not equals to 0, right? So now if we simplify it, we will have x cannot equals to 1/2. So it has to satisfy both conditions. X not equal to 0 and x not equals to 1/2. So that means on the number 9, you have a 0, 1/2, 1, negative 1/2, infinity, 3/2, negative 1. X can equal to anything but 0 or 1/2. So that means should be anything that I highlighted. So how do we represent that? Well, the domain of the composition function should be from negative infinity to 0, parentheses, union, the second part in here, which is from 0 to 1/2, and union, the right part, which is 1/2 to infinity. That means x can equal to anything but 0 and 1/2.